All right, so let's see where that particular thing got us. So it's kind of hard to tell because of the collisions. Hey, we almost have some orbits. Here, let's restart this. There we go. So now we have some things that are actually colliding together. Hey, that's kind of a cool, like, double orbit. So one thing you may notice is that eventually everything leaves, which is kind of a problem. So if we're going to be able to see what these other masses do, we should probably have some way of zooming out. So I think that's going to be the next thing that I'm going to work on. So adding in some sort of zooming. So the basic problem is that when we have all of our objects leave the screen, like, we're not actually able to see any more of the simulation. So what I'd like to do is somehow still be able to continue watching a simulation for a longer period of time. So I'm going to create a method here where we check to see if we need to zoom in, and then we're going to do that down here. So now I need to make a decision about how I'm going to zoom in. So I think what I'm going to do is I'm going to follow whatever the largest mass is, because that's the thing that's going to exert the most force on all the other objects, so it's most likely to bring all the other objects back to itself. So I think following whatever the largest mass is once it leaves the screen is going to be what I want to do. And also, if we get to the point where most of the masses have either joined together or are way off the screen, I'm probably going to want to zoom out, like basically take all of my x and y coordinates and like kind of double the scale, so divide them by 2. Based on whatever the center of the screen is. So first of all, I should probably check to see if I do need to recenter. So check for recentering. So I need some way of checking to see if my mass is still inside of this area. So I'm going to actually have to walk through all of my masses and figure out which one is the one that is the largest. I could create some variables here, but because I'm doing this every step, I don't want to like constantly be creating new ones. So I think I'm going to create them up here where the rest of my variables are set. Maybe some sort of variable that keeps track of whether or not my biggest mass is inside the area of the screen, and then maybe keep track of what the index of that particular mass is. So the way I check is I'm basically going to figure out whether or not an object is entirely inside of the screen by walking through every single object, figuring out which one is the largest mass, and then taking a look at that particular object, checking its x and y coordinates based on the center of the screen. So let me start with, all right, there's no object that's currently inside of the screen. Then I'm going to go through and set the index of my object to be 0 to start with, so the first thing in my list of objects. And then I need to find the largest mass. What I'm going to do is walk through my list of objects again. You've seen this many times now. So A is less than total objects, A plus plus. And then if the mass of whatever object I'm looking at is greater than or equal to this one that I'm saving. So this index is going to be keeping track of which one is the largest one I've seen so far. So if the new one I'm looking at is bigger than the one I saved basically before, then hey, it should be that one now. So when I'm all done with this loop and I've walked through every single one of my objects, and whichever one was the greatest will be assigned the value of index. So maybe if the 7th one was the largest one, index will be 7. So now, once I have this object, I need to check if it is in the screen. So I'm just going to do a quick check on its coordinates. So if the x coordinates of that index are greater than or equal to 0, and the x coordinates of that object are less than or equal to the width. If I'm looking left to right, it's the width. And the y coordinate of that object is greater than or equal to 0, and the y coordinate of that object is less than or equal to the height. So basically this is saying if the x is between 0 and the width, and the y is between 0 and the height, then hey, you're in the screen. And inside, which is how I'm checking to see if that object is inside, is now a 1. Hooray, away we go. So this says whether or not we are inside the window. Now if we're outside the window, that means we need to do our recentering thing. So that's where the actual zooming part comes from. If inside is still equal to -1, use 2 equal signs when you're checking an if statement, by the way. I'm not taking -1 and putting it into this variable inside. I'm saying, are these two the same thing? So watch out that if you're in an if statement or a for loop or a while statement, you use 2 equal signs. Then I need to actually figure out where to put my largest mass. So I need to recenter the largest mass. So my new location is going to be the width of the screen divided by 2, which is the center of the screen, minus whatever my x-coordinate is. So the idea being, like, I'm going to take this central point and find out what the difference between it and the current x position of my mass is. And I'm going to do the same thing with my y, which is going to be the height. Height? That's how you spell height. Divided by 2 minus the y-coordinate of that index. All right, so now that I know those things, this will move my object to that center point. So if I take my current x position and subtract off this difference, that will take my mass and recenter it. If this is my largest object that's off the screen and this is the center point, I need to take the x-coordinate, subtract that much, and then the y-coordinate, subtract that much. Now if I'm zooming, that means if I'm recentering around this object, I actually need to do that to all my objects. So this object also needs to go this same amount over and up. And this object needs to go the same amount over and up. So I need to walk through all of my objects to do that. So rather than just doing the one that's at that index, I'm actually going to just go through all of my objects. A is less than total objects, A plus plus. And I'm going to take their x-coordinate and say, hey, x-coordinate, you should subtract off whatever that difference of x is. Actually, no, you should add it, because this is the subtraction we needed to make. So now, if that is a negative, we need to add it on. Otherwise, that would be backwards. Negatives are funny that way. So now take the x-coordinate and add on the difference. So basically, move it over by the amount that the largest mass is going to move in the x position, what the largest mass in the y position. And I'm doing this to all objects. So by the way, this will also actually happen to get my largest mass and put it in the right spot. So that's good. So what do we have so far? So this kind of looks like the largest mass. Let's see what happens. Hey, it jumped into the center again. Now the problem is that I still would kind of like to zoom out. So there may be objects way off the screen in either direction, and every time that I jump out of the center window, I probably want to make sure that I recenter things and re-zoom out. So besides just recentering things, let me also do a zoom. So basically what this means is I'm going to be scaling everything in the x and y direction by 0.5 divided by 2. So let's go through all our objects. Because we've never done that before. Some of you may be copying and pasting, and I applaud you for that, assuming that you do everything right. Our center mass is not actually going to zoom. We're basically going to zoom everything around that. So I want to make sure that I'm not picking out my center. So that's what this is doing, is saying, if this object is the one in the center, ignore it. I'm going to recalculate a difference x, which is going to be whatever the x-coordinate of my center point is, minus the x-coordinate of whatever object I'm looking at. So that particular one. Same with the y, because, you know, it's always that way. I'm going to take everything, the difference between their x values, and basically divide by 2 and move every object that much closer in the x direction, which basically effectively scales it by 2. So if I'm a distance of 2 away, I'm going to make it a distance of 1 away. So the x-coordinate of a particular object is now whatever it was, plus the difference away from the center point divided by 2. So change its x position slightly so it is there. Same with the y-coordinate. It's going to be whatever the y-coordinate was. All right, so now all of those x and y coordinates should be updated. Now the other problem is that I'd also like to, if I left it this way, all of a sudden everything would have gotten faster because I'd have scaled down the positions, but I wouldn't have scaled down the velocities. So I better redo that. So the x velocity will be the x velocity of A divided by 2. And the y velocity component of A is going to be whatever it was divided by 2. And also I'm going to scale down the size so things don't magically grow larger. That would be weird. Now I don't need to worry about acceleration because in the force equation up here, I am figuring out acceleration every time. I'm resetting them to 0 and then recalculating them. So I'm OK there. But this will effectively zoom out. It's also changing their masses, but as far as our scale goes, that's appropriate for what we're doing. All right, what do we got? So that was the largest mass. So now it's going up this way. And you notice that it scaled these down, so they're a lot closer together. Kind of funny, actually. Most of the interesting stuff is happening up here. Oh, well. And hopefully, eventually, these two will attract by each other back together, and we will have a giant black hole. I guess that's what we want. Okay.